Alrighty, y'all. So section 2.3 is going to go over domain and range. Okay, so we played with the domain and range a little bit yesterday, as far as functions go, but today we're officially going to figure out how to find a domain and how to find a range. Okay, so I'm going to give us some definitions again. All right, so y'all, the domain is going to be the set of all x values. Um, of a function. Okay, so it's going to be the set of all x values of a function. Okay, now the domain must only include all x values that produce a real number output. Okay, so at this point, the only thing we're concerned about on a domain is fractions, and we'll get in a little bit into that a little bit more later. But the thing about fractions is the denominator of a fraction cannot equal zero. Okay, so if there's any numbers that make a fraction equal zero, we're going to have to kick them out of the domain. So the domain cannot include any numbers which make the denominator of a fraction equals zero. Okay, y'all, because that means, say I have a value that I put into that denominator, it made that fraction equal zero on the bottom. Well, if you try to divide anything by zero, that is undefined. And y'all, undefined is not a real number. There's no way to graph anything that's undefined. So that's why any numbers that make that happen, we're going to exclude them out of our domains later, okay? All right, so that's our domain. The range. So really the range is the set of all y values of a function. Okay, and the y values, you can also look at them. You can look at the x values as our inputs, and the y values would be looked at as our outputs, okay? All right, y'all. So what you're going to do, the first few examples are going to give us the graph, and there's a few things they want us to find off of each graph, okay? So I'm going to start with this number one we got. All right, so for number one, they're giving me this graph, and I got what? 1, 2, 3, 4, 5, 6, 7 points on it. So for this problem, they want me to, so it says for the graph, determine the following. All right, so for A, they want me to find f of -1. So what they mean by this, remember, if they give you a number in place of the variable here, that's the number that represents what the variable is. So since they're putting a -1 in here for the x, what they want me to do on this problem is they want me to find the y value that has a x value of -1. All right, so they're putting a -1 in for the x. So they want me to find the y value on the point that has the x value of -1. So y'all, what I would do on the x's, I would come over here to where -1 is. So they don't list this, but -1 would be right there on the x-axis. So what I need to know is, what is the y value of that point? And y'all, I'll pull up my chat. So y'all, what is the y value of the point? -1, and Mackenzie, what you got up there? 5? Perfect. Because y'all, if you go straight up, that point has a y value of 5. So for number 1, we would put 5. And then it won't be. On B, they want the domain. And on that, they're going to give you they give you these little squiggly brackets. So all we got to do is put all the x values in here and separate them by a comma. So what I'm going to do, I'll look at each of these points and come straight down and see what the x values are. So my first one, if I come down, its x value was -5. The second point, if you come down, has an x value of -4. It looks like they're going by ones, right? So this one's going to be -3. That one comes down at -2. I got a -1 there. This one's on the y-axis, so that x value is 0. And then finally, my last point, if I come down, has an x value of 1. So remember, on the domain, I was just looking for the x values. Okay? All right, y'all, now look at C. C is pretty much the opposite of A here. So C, what they want is any x values for which f of x equals 7. So any x values for which f of x equals 7. Remember, f of x, this whole function is like the y value. So they're wanting to know the x values when I have a y value of 7. So y'all, let's find 7 on the y values. 7 is sitting right here on my y-axis. So anything on that horizontal line going straight across would have a y value of 7. So y'all, if you notice, I got 2 points. I got one over here, and then I got this point right here. So what they want to know are those x values. So they're going to have x equals, and then I'm going to put in the x values that made that happen. So y'all, I'll give us the first one. Over here had a y value of 7. The x value was -5. All right, y'all, I got another one sitting here at 7 on the y-axis. So if we go straight down on that one, what you got, Claire? Y'all got a 1? Perfect. So on that one, I had 2 x values that had a y value of 7 on that one. And y'all, let's see what they got on D here. D wants to know the range. And on that one, they're going to give us the curvy brackets again. So my range is all the y values of my points. So y'all, usually on my range, I'm going to go from the smallest range value to the highest range value. So my lowest point is right here. If I go straight across to the right, it has a y value of 4. There y'all. The next points I got, the next lowest points would be these 2 points. And if you go straight across, these 2 points have a y value of 5. Now, we don't have to write the 5 twice. We only have to write it once. So, y'all, I will say there's 2 more. What are y'all going with? McKinsey, what you got? 6 and 7? Perfect, because I got these 2 points, had a y value of 6. And then these 2 points we know had a y value of 7. Hey, y'all, so that's how you do this first one when it gives you the dots on your graph. Now, the second problem I do, it's going to be pretty much the same thing, except they're going to give us a graph of some lines on it, okay? But we're going to do the same thing as we did on this one. So let me give y'all a second to write that one down, and then we'll move into number 2. Now, y'all, so I'm going to put my next sheet up here for us. Okay, y'all, so pretty much this is going to be the same things here. So the first thing they want me to do, we're still going to use the graph. So on this one, for A, they want me to find f of 3. So y'all remember, they're giving me the x value. So they want us to find the y value that corresponds to an x value of 3. So y'all, what are we going with? So let's find 3 on our x-axis. Here's 3. So go straight up, y'all, and so let me see if I can zoom this in just a little bit and get my focus on that. All right, can y'all see that better? Okay, so Mackenzie, I think you're right, because here's 3, and if I go straight up, I'm looking at this point right here, and it has a y value of 2. So for that one, we would put a 2. Hey now, so here's a new one for the domain. Hey, also for this one, notice this graph goes forever to the right. It's going forever to the left. So it's covering all these x values in either direction. So when you got a graph that's covering all the x values in either direction on the domain, we say that this domain is all real numbers because it's covering all the positive directions. And if you notice, it's covering all the x values in the negative direction. So for this domain, it's going to be all real numbers. Now remember, that's different than the one I had a while ago. The one while ago, they just had 7 points on it. But y'all, these lines are going through all those x values, okay? Now later on, we'll learn another way to write this. These graphs, when they head off to the right, we say these graphs are headed towards positive infinity. And if they're heading off to the left, we say that's headed off towards negative infinity. So when the graphs are going both directions, y'all, it is definitely all real numbers. All right, so how about this one? Any x values for which f of x equals 2. So notice, here they gave me the x, I found the y value. Here they're basically giving me the y value, and I'm looking for the x's that had a y value of 2. So that would be x equals, all right, y'all, so let's see. Here's 2 on the x-axis. So it looks like y'all got one of them is that 3 for sure. But y'all look, this thing goes on across here. And it looks like we got a second point right in here. So that second point, if you come straight down, would be, what's that, 7? And then we got them both, okay? Now, y'all, here's where it's going to be a little bit different for the range. So look at this. The range is my y values. But y'all listen, the range is not going to be all real numbers on that one. Because look here, the smallest point is on the x-axis, which has a y value of 0. There's no parts of that graph that are negative in the y direction. So y'all with me on that? See, the x's did go both directions on the x-axis, but the y values, they only go up into the positive direction. So for our range, we would pick the picture that had a y, such as, so you list the variable for the range, which is the y. This bar means such that. Well, what do I know about my y values? The y values are greater than or equal to, well, y'all, what's my smallest y value? And then the smallest one is this point. What you got, Mackenzie? 0, perfect. Because that point is the smallest y value, and it is at 0 in the y. So you would pick the one that had the greater than or equal, and then you would put the 0 into it and be done with that, okay? So notice, the x's did go both directions, but the y only went in the positive direction. So, y'all, that's just getting you a little bit used to doing domain and ranges of a function like that, okay? All right, so we're going to get back into how do we find um, the domain of a function, not a graph. This is just going to be a function they give us. So we're going to be finding the domain of a function. Now, this is something we're going to do quite a bit in this class, is finding these domains. So we're going to find it for a function. So if you remember up here, the only thing I said we were really worried about on our domain was a fraction. And remember, the domain could not include any numbers that made the denominator of a fraction equal 0. Okay, because anything that has a zero in the bottom of a fraction is going to be undefined. Okay, so the first thing, if the function does not include a fraction with a variable in the denominator, then the domain is all real numbers. Okay? So if I don't see a fraction, automatically my domain would be all real numbers. That means no matter what numbers I put in for the x values, I'm going to get a y value that's a real number. Okay? Now, if the function does include a fraction with a variable in the denominator. So if my function does include a fraction with a variable in the denominator, I'm going to set the denominator equal to 0. Because what I'm going to do, by setting the denominator equal to 0, I can solve that for the variable, and that will give me the number that I got to exclude from my domain. Okay, so I'm going to set that denominator equal to 0. I'm going to solve for the variable, and then I'm going to exclude any of those solutions from the domain. Okay, now, since we're just starting out the year, these domains, we're only going to be excluding one number. But y'all, later on in life, some of those domains we might be excluding two or more numbers from, okay? But for right now, just getting used to it, we're only going to be really excluding one number, okay? All right, then we'll write these in, write the domain in set builder notation. And y'all, that's where you would just use the fancy little brackets. You would list your variable, which is the x, and then you would put the conditions. Now remember, that bar means such that. Oops, let me pull that down just a little bit more. So x such that, and then you put the condition like x is a real number, and x cannot equal blah, blah, blah. Okay. Now, if you don't have to exclude any of the numbers out of your domain, if you didn't have a fraction, you'll just put x such that x is a real number. But if we do got to exclude numbers because of fractions, then we'll write it like this and use that not equals to represent what numbers we're sort of going to kick out of our domain, okay? So y'all, they're not too bad. Let me show you some examples of this. So y'all, for these examples, they're going to say, find the domain of the function. So let me just give you one real quick. What if I had f of x equals 7 over 3 minus x? So I do have a fraction with a variable in that denominator. So what we said was we're going to set the denominator 3 minus x equal to 0. So now when I solve this, that'll give me the number that I cannot keep in my domains. Now this, and you can pretty much tell what number is going to make this equal 0, right? 3 minus 3. So if that x equaled 3, 3 minus 3 would give me a 0, which would make that undefined. So that means I'm going to kick that 3 out. But officially, I'm going to solve this for the x. So I'm going to move the 3 over, and I would subtract that over. So those 3's cancel. That gives me negative x equals a negative 3. Now remember, we want the x to be positive. So anytime you got a negative in front of the x, it's like a negative 1x. So to make this x positive, I would divide both sides by negative 1. So that negative divided by negative makes that a positive x. And then negative 3 divided by negative 1 makes that a positive 3. So we were right. If we put a 3 in there, that makes that equal 0. So my domain then would be x such that x is a real number and x cannot equal a positive 3. Okay, so that's how you're going to put the answers in. If you exclude a number, just put that number in it and be done, okay? All right, so y'all got questions on these before we do these domains? All right, so y'all looking good, okay. All right, so for their examples, these start at number 3. So this one was just a warm up for us, okay? So for their number 3, they're giving me f of x equals 2 over x minus 11. All right, y'all. So are there any numbers I need to exclude from this domain? Or would it be all real numbers? Or what would we put? Right, definitely, we're going to exclude 11. So since I do have a variable in the bottom, if you want to, you could set x minus 11 equal to 0. Solve that for the x. So all I got to do is move that 11 over by adding 11. And y'all look, that gives me my x. Those cancel, and I get 11. So good job. So my domain would be x such that x is a real number and x cannot equal a positive 11. Okay? Oh, yeah, what about this one? P of x equals 2x minus 3. All right, so what would that domain be? Oh, so I sort of got y'all on this one because y'all don't even see a fraction there. So remember what we said over here. If the function does not include a fraction with a variable in the denominator, then the domain is all real numbers. We all? There's no fractions here. So automatically my domain would be x such that x is a real number. That means I can put any number I want to in for that x and I'll get a real number out of it, okay? I can multiply any number by 2 and then subtract 3 from it, okay? All right, y'all, this one's on y'all. I got p of x equals x squared plus 4. Exactly, that's all real numbers again because there's no fractions. So x such that x is a real number. And y'all, we just want y'all to realize in this section, really, if it does not contain a fraction, then that domain has no restrictions at all, okay? All right, then let's move on to what we got, number 6. This one is a g of x equals 3 over 2 minus 7x. So see, this one's a little trickier to see what kind of numbers I need to exclude. So I'm just going to set it equal to 0 and solve that and see what we get, okay? So I'm going to set the 2 minus 7x equal to 0. Now notice, I do not care about what's on top of the fractions. The fraction on top, it can be 0. It can be any number. The only restrictions are these denominators, okay? So that's why I'm only playing with the bottom. All right, y'all, so we're going to solve that for the x. We're going to move this 2 over first by subtracting that. So look here, those cancel. I get negative 7x equals negative 2. So I need to turn the 7x. The negative 7x needs to be a positive 1. So I'm going to divide both sides by negative 7. So those cancel, giving you a positive 1x. And then a negative divided by negative makes this a positive. And y'all, there's really nothing I can do with that 2 over 7. So I'm going to leave that as a 2 over 7. Okay? So if you put that 2 over 7 in here, the 7's cancel. And then you get 2 minus 2, which makes that 0. So that's why we got to keep that fraction out of our domain. So our domain would be x such that x is a real number and x cannot equal, what do we get, 2 over 7. Okay, y'all, so that's how you're going to do these domains. We got 2 more left, so let's knock these out. All right, number 7, they're giving me p of x equals the absolute value of x minus 10. All right, y'all, what's that domain? So that one's on y'all. Claire, what you got? Real numbers, perfect. I got absolute value, but I do not have a fraction. So that means any number you give me for x, I can put into that, take the absolute value, and subtract 10, so there's no restrictions. So x such that x is a real number. Well, so the last one here is a p of x equals, ooh, they're turning it up here, x cubed minus 10. All right, so what y'all think? Real number again? Perfect. Because y'all, any number you give me, we can throw into that and we can cube it, and then we can subtract 10. So there's no restrictions again. So x such that x is a real number. So y'all, the moral of this section is we want y'all to realize that the only thing we're worried about in a domain is the denominator of a fraction that has a variable, okay? Other than that, it works for all real numbers, okay? So y'all, that was 2.3. So let's get into 2.4. So y'all are going to have more fun in 2.4, I think, if you like algebra, right? All right, y'all. So we'll get a start on this, and then we'll take a break at about 11 here. So for 2.4, this is called the algebra of functions. And y'all, there's four functions I'm worried about, or four, what do you say, operations we're worried about here. The first one is f plus g of x. F plus g of x is f of x plus g of x. Now, the only thing we can do when we're adding two functions is combine like terms. So when we're adding, we can only combine like terms. Okay? And those variables got to look exactly alike in order to be added. X squareds can only add to x squareds. X's can only add to x's, and so on, okay? All right, next is f minus g of x. That's going to equal f of x minus g of x. Now, subtraction is similar to adding. There's only one thing we got to do before we combine like terms. You got to distribute that negative into the second parentheses. So you're going to distribute the subtraction through the second parentheses. Then combine like terms. So that's why we gave y'all them problems on the support the other day where you had to distribute that negative through it to get you ready for this. And the support today will actually have more problems where you're having to distribute that negative, okay? You're going to distribute the negative first, and then you're going to combine like terms. So really the only thing you can do when you're adding or subtracting is combine like terms, okay? All right, y'all, the next operation is multiplication. F times g of x. That's going to be my f of x times my g of x. Now, multiplying is the place where I'm going to be changing the variables. If I have an x times an x, I'm going to add those exponents and get an x squared and so on, okay? So, just remember, recall that x to the a times x to the b equals x to the a plus b. When multiplying variables, we add those exponents, okay? Now, multiplying might be distributing. It might be foiling. So some of these we're going to have to actually foil. And then all kinds of fun stuff, okay? So we got one more left, and it is division. F divided by G of X. That's going to equal my F of X over my G of X. Well, y'all, what can G of X not equal? So when you got a fraction, remember, G of X cannot equal 0 for us, okay? So anytime you're given a function and you got a denominator, you got to put that restriction on it, okay? So I can divide any functions as long as this function on the bottom does not equal 0. Now, they don't kill us a lot with the division in this section. Um, but yeah, that's what we would do, okay? So here's what we're going to be doing. We're going to be adding, subtracting, multiplying. And I think there's one where we divide, but they give me a number to put in for it. So it's not too bad, okay? All right, y'all. So let's start with my first one. We're given f of x equals x squared plus 2. And g of x is going to equal x minus 1. They want me to find f plus g of x. All right, so when I first start these out, I'm going to come over here and do f plus g of x. I always start out by putting my functions in parentheses. So since I'm adding, I'm going to have my first function added to my second function. Well, f was x squared plus 2, and g was x minus 1. So what's going to happen here, since you're adding, you can drop the parentheses and everything will stay the same. So I get an x squared plus 2, and then that's going to be plus my x, and then minus my 1. So tell me, remember it said the only thing I can do when I'm adding is combine like terms. So do y'all have any like terms that we can maybe add together here? So what you got? 2 and negative 1? Perfect. That's the only things we can add together, right? Because remember, this x squared does not match the x all the way. So I'm just going to put them in what we call descending order. I'm going to put in my x squared first. And then I'm going to bring in that plus x. And then we had what? 2 and negative 1. So 2 minus 1 leaves me a positive 1. And that's the answer MathLab wants right there. Cannot go any further. So y'all really, adding's not too bad on these, okay? Does anyone have a question on that one? All right, so y'all let's play at this one. On number two, they're giving me f of x equals x squared minus 4. G of x equals x plus 1. They want me to find f times g of x. So they want me to do a little multiplying on this one. So f times g of x will equal my f times my g. So if I put these parentheses right up next to each other like that, that represents multiplication, okay? So let's put our f in, which is x squared minus 4, and my g, which is x plus 1. Ready, y'all? So two things being multiplied by two things. This is where we taught y'all how to FOIL. So this FOIL just lets you know you got to multiply four things together, okay? So y'all, here's what we're going to do. FOIL, the first one's from each parenthesis. You're going to multiply x squared times x. Now remember, this x don't have an exponent. So since it don't have an exponent, you would treat that one like a 1. So an x squared times an x to the first is going to give me an x cubed. All right, the O is the outermost. Well, that's going to be the first one and the last one. So x squared times a positive 1 is a positive x squared. All right, so now I multiplied the x squared times both of these. Now I'm going to multiply the negative 4 times both of these. So the I is the innermost. That's going to be the negative 4 times x. And negative 4 times x is a negative 4x. And then the L is the last ones from each parentheses. That's going to be the negative 4 times 1, which is negative 4. Now, at this point, I would look for any like terms, but y'all, I don't have any like terms. I got an x cubed, an x squared, a negative 4x, and a negative 4. So since I don't have any more like terms, that would be my final answer. And notice it's already in descending order. My cube, my square, then my x, and then my number. So y'all, questions on that one? All righty, y'all. So let me stop this share for a second here. And I'm going to pause it. All right, also for the third one here, let's see, they're giving us f of x equals x squared plus 1. G of x equals x minus 2. They want us to find g times g of x. All right, so they sort of throwed a little curveball here. They want g times g. They gave me the f, but we're not even going to use the f on this one. We're going to do what they're wanting. So we're going to come over here. G times g of x will equal my g times my g. Okay. So what was G? G was x minus 2. So we're going to put an x minus 2 in both parentheses. All right, so once again, I got two things times 2. So I'm going to FOIL this one out. All right, y'all. So we start x times x gives me an x squared, because remember, there's a 1 here and a 1 here. And I added those exponents and got a 2. Then I'm going to do the x times negative 2 is a negative 2x. Now we start with the negative 2 and distribute it. Negative 2 times x is a negative 2x. And y'all finally, negative 2 times negative 2, a negative times a negative makes that a positive 4. Then I'll tell y'all the truth. What messes a lot of people up on this problem is they add these like terms and they cancel them. Y'all, those don't cancel out. They're both negative. So we're just going to double it basically. So bring down the x squared. Negative 2 plus negative 2. When you add two negatives, it's going to stay negative. That's another place where people mess up. When we multiply two negatives or even divide two negatives, that gives us a positive. But that does not apply to adding. When you add a negative to another negative, it's still negative. So y'all, negative 2 and negative 2 would give me a negative 4x. And then at the end, bring down that positive 4. At this point, you don't have any more like terms, so you would be done. Okay? All right, so the thing to remember on this one is when you're adding two negatives, they will stay negative, okay? All righty, y'all. So let me do one like this, number 4. F of x is going to equal negative 2x plus 4. G of x is going to equal x squared plus 7. They want me to find f of negative 6 plus g of a negative 6. So f of negative 6 plus g of negative 6. Technically, they could have said f plus g of negative 6. Okay? Because that's really what we're finding here. F plus g of a negative 6. Since we're putting the same number into both the functions, we can shorthand it like this. So what that's going to do is give me my f function plus my g function. But y'all, here's the difference. Since they're giving me numbers in place of the variable, I've got to put a negative 6 in for the x and a negative 6 in for that x. So this first one will give me negative 2 times negative 6 plus 4. The second one, putting a negative 6 in for g, gives me a negative 6 squared plus 7. Remember, put these negative numbers inside their own parentheses, okay? So order of operations, I'm going to work inside the first parentheses and work inside the second one. So the first thing I would do in the first parentheses is multiply before I add. So I got a negative 2 times negative 6 will give me a positive 12 plus my 4. And that's going to be added in here. The first thing you would do is square the x and then add. So negative 6 times negative 6. A negative times a negative is a positive. So that's going to be a positive 36 plus my 7. All right, so the only thing left in both of my parentheses is to add. So if I do 12 plus 4 in the first parentheses, I get a 16. And I can bring that out now because there's nothing else to do to it. And then that's going to be plus my 36 plus 7 gives me, what, 43? And that one can come out of the parentheses because there's nothing else to do to it. So now I got my f of negative 6, which was 16. My g of negative 6 gave me 43. Adding them together, I'll get my final answer. And that's what? 59. Okay, so if they give you numbers here in place of the variable, you got to come to an answer that's a single number. If they give you x's, all you can do is sort of simplify the expression, okay? So that's sort of the differences on these. All right, y'all. Number 5 will be the same thing. F of x equals negative 5x plus 13. G of x is going to equal x squared plus 15. All right, y'all, let me see what they want us to find. They want us to find f of 6 minus g of 6. So they want us to do a little subtraction here, okay? So remember, since they both have the same number being put in, I can technically write that as the f minus g of 6. Okay. Now, if they was giving me different numbers for those, then I couldn't do this shorthand. But I can since they both are having a 6 on them, okay? So that's going to equal our f minus our g. All right, so f, I'm going to put a 6 in for that x. That's going to give me negative 5 times 6 plus 13. G, I'm going to put a 6 in for that x. And that's going to give me a 6 squared plus 15. So once again, I'm going to work inside of each of my parentheses. So y'all, the first one I'm going to multiply before I add. So negative 5 times 6 is a negative 30 plus my 13 minus, here you would do the exponent first before you add. So 6 times 6 is 36 plus my 15. Hey, y'all, let's see what we get here. All I got to do in each of these is add. So negative 30 plus 13 is a negative 17. That's going to be minus my 36 plus 15. Oh, what's that? 41, 51. So I've got a negative 17 minus a 51. So these are both negative. So add the numbers and keep them negative. Remember, this is like negative 17 plus a negative 51. So add those two numbers. I get one a negative, let me see what that chat's saying. Negative 68, perfect. And then be done with that one. Okay. Hey y'all, let me ask y'all, who's on iPhone today? It's not showing a name, and I need that name for my row. So who is iPhone? iPhone, are you in class? I'm gonna have to kick them out. They're not responding.
I'm here.
Oh, no, 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 not you. I got one that says iPhone for their name, and it's not letting me know who they are.
Oh,
Yeah, so if they come back, I guess they'll let me know who they are. Okay, y'all, so that puts us on number 6 here. All right, so that one is more multiplied, so I'm going to do like number 7 here. All right, also this one I got f of x is going to equal negative 17x plus 7. G of x is going to equal x squared plus 9. We're going to find f of a negative 7 divided by g of a negative 7. So really, this one is really one of the only ones where you're going to see any division, okay? Oh, y'all, hang on. So Monty, was that you on the iPhone? If it is, then you can bring it back on and I'll put it back in. All right, y'all, so here we go. F of negative 7 divided by G of negative 7. Now, I could have just hit F divided by G of a negative 7. So, y'all, that's going to equal my F on top. And remember, I'm putting a negative 7 in for the X. So, I'm going to have negative 17 times negative 7 plus 7 over my G of negative 7, which will be a negative 7 squared plus 9. All right, y'all. So you work the top like it was in parentheses, and you work the bottom like it's in parentheses. If you did this, if you were to do this problem in your calculator, you would have to put parentheses around the top and the bottom. So you would have extra parentheses around the top and the bottom if you were doing this on the calculator, okay? Unless you use the fraction bar. So I'll work this by hand, but let me show you how I can do this on that calculator. Because y'all, I got my calculator license. So let me bring that up. So now this is a little bit easier to see than my calculator yesterday. So I'm going to put it in like a fraction. So I would hit the green alpha button and the y equals and enter. That gives me the fraction notation. So on top I had a negative 17 times my x, which was negative 7, plus 7. Then I would arrow down and do negative 7 squared. So since I'm squaring a negative number, I'm putting that negative number in parentheses and then squaring it and doing my plus 9. So y'all just remember, negative numbers need parentheses when you're squaring them, okay? All right, y'all, so what that's going to do when I hit enter, it gives me the final answer of a 63 over 29. So let me do that by hand and show you how they got to that. All right, so the first thing I'm doing is I'm going to work on top. So y'all figure out what that is. Negative 17 times a negative 7. And that should end up positive, right? So 119 And I still got my plus 7. On bottom, we got a negative 7 squared, which is a 49, plus my 9. All right, y'all, so let's add that top. 119 plus 7 gives us what? 126. On bottom, 49 and 9 is a 58. So really all we got left is to reduce this. So if nothing else, I know they're both going to divide by 2 on this one, okay? Because they're both even numbers. So to reduce it, I'm going to divide both of these by 2. So 126 divided by 2. Oh, what's that give me? 63. And then y'all, what's that? 58 divided by 2. We got Judy 29. That sounds good. And I think what we got on the calculator was what, a 63 over 29? So that would be our final answer. Oh, let me do the number 9. Number 9. Oh, so 8 was just adding. It's not bad. Um, so number 9, they want me to find f minus g of x when f of x equals 6x minus 8 and g of x equals, oh, let's see, 4x minus 6. All right, y'all, so here we got subtraction. And they're not giving me a number to put into this one. So it's going to be a little different than the subtraction when I did have numbers, okay? So here we go. F minus g of x will equal my f minus my g. Well, my f is 6x minus 8. My g is a 4x minus 6. So, y'all, this is the one where I said on subtraction, you got to distribute your subtraction through the second parentheses. Okay, that's my first step. So bring down the 6x minus 8. Distribute that subtraction. So a negative times a positive will make that a negative 4x. And y'all watch this. That negative times a negative will make that a positive 6. So this negative outside the parentheses changes both of these signs. The positive turn negative and the negative turn positive. At that point, can we go any further? All right, so we're going to combine like terms. So if y'all were to combine like terms, what answer would you end up with? All right, so let's see. You looks like you did the x's, and 6 minus 4 left me 2 x's. Oh, I think I got Mackenzie on the sign. Claire, yours looks, I think Claire is right on hers. Because y'all look here, you got a negative 8 and a positive 6. So, yep. So, since the negative's larger, that would be what? A negative 2 on that one, okay? So, y'all watch them signs on that. That's where we get y'all the most at in math. All right, y'all. So, the main thing on this is to distribute the subtraction, okay? So, I'll let y'all catch up on that and then we'll move to the next one. All righty. All right, y'all. So this will be like number 10. And it's another subtraction I wanted to play with. So this one, they're going to let f of x equal negative 4x plus 2. G of x is going to equal x squared minus 2. But y'all watch this one. They want us to find g minus f of x. So the same thing as number 9, except they reversed it. Number 9 was f minus g. This one's g minus f. So be careful on this one. It'll equal my g minus my f. Well, y'all, g is x squared minus 2. And then f is a negative 4x plus 2. All right, so we're first going to draw our parentheses down. So I know what's coming out of here. X squared minus 2. Y'all, what I want to know is, what's the next two things I would write here? What would y'all write next? Your next two terms on this. Uh-oh, I got y'all. Oh, look at Claire's coming through. Let's see. So y'all are sort of in the right area, but let me ask y'all this. Y'all distribute that negative. What's that negative times that negative 4x giving me? A positive 4x. There you go. And then what's that negative times that positive 2 giving us? Right, so that negative times that 2 is going to make that one a negative 2. There you go. So y'all got to be really careful distributing here, okay? Negative times negative was positive. Negative times positive was a negative. All right, now the only like terms y'all got are these negative 2's, but y'all are both negative, so they're not canceling, okay? So bring down your x squared, put them in descending order, and then your positive 4x, and then a negative 2 plus a negative 2 is a negative 4. So remember, adding two negatives stays negative. Oh, yeah, 11's a repeat, so let me do 12. So 12 is sort of interesting here. They're giving me a f of x equals x squared minus 10. They're giving me a g of x equals 17 minus x. Now look what they want me to find. They want me to find f times g of a capital N. So they're throwing all kinds of curveballs at us. So, first of all, f times g of a capital N will equal my f times my g. So these are being multiplied, so I'm putting my parentheses right next to each other. So I'm going to put my f here and my g here. But y'all look here. They don't have an X here. They got an N. So that means they want me to put an N in for that X. So instead of X squared minus 10, this will be N squared minus 10. And then the same thing here. They want me to put an N in for that X. So this one will be 17 minus N. So that was the first step, was getting the right variables in here according to what they're giving us, okay? So whatever they got in the parentheses, that's what's going in for these variables, okay? All right, this is 2 things times 2. So I'm going to FOIL this again. So y'all, here we go. N squared times 17 is a 17n squared. N squared times negative n is a negative n cubed. Remember, 2 plus 1 equals 3. All right, now I'm going to do the inside. Negative 10 times 17 is a negative 170. And y'all watch this sign on this one. You got a negative 10 times a negative n. So a negative times a negative is a positive 10n. Now this one, they'll tell you they want this one definitely in descending order. So the highest exponent is a 3. So I'm going to bring out my negative n cubed. Then I would have this positive 17n squared. Then I would have my positive 10n. And then at the end is my number, negative 170. So remember, when you put them in descending order, they got to have the same signs there, okay? So the n cubed had to stay negative, and the 170 had to stay negative on those, okay? All right, y'all. So now what they're going to do, they're going to give me 2 functions, and they want me to find the domain of the sum, the difference, and the product. Not the quotient, just the first 3, okay? So these will start at, looks like these are starting at 14. So let's play with one of these. So for the functions, determine the domain of the sum, difference, and product. All right, y'all. So the functions are going to be f of x equals x squared. G of x equals 4x minus 8. So this is like 3 problems in one, okay? We're going to find the domain of the sum, the domain of the difference, and then the domain of the product. So I'm going to start with the sum. So sum means adding, okay? So that'll be like f plus g of x. That's going to equal my f plus my g. So y'all, my f is x squared, and my g is 4x minus 8. So y'all, knowing this is your functions, any guesses on my domain? So it will start like this, x such that. Oh my God, Mackenzie, perfect. Perfect. It's all real numbers. Because y'all, we do not see a fraction there. So good job, Mackenzie. Since there's no fractions there, this is good for all real numbers. So no restrictions on that one. All right, y'all, what about the difference? The difference will be f minus g of x. That's going to equal my f minus my g. So that'll be the x squared minus the 4x minus 8. All right, so what's this domain? So good job, y'all. It's going to be the same. It's going to be all real numbers. Once again, there's no fractions here. And what was our next one, y'all? We had to do a product. So a product will be f times g of x. That's going to equal my f times my g. So that'll be the x squared times the 4x minus 8. All right, any ideas about the domain of the product of these two functions? So that for this one, but the same yet. Same as all real numbers. Good job. Now I'll tell y'all a little trick on these. The sum, the difference, and the product, they're always going to have the same domain. Okay. If one of those is all real numbers, they're all three going to be all real numbers. If they all have something that's being kicked out, if one of them has something kicked out, they'll all have the same number kicked out. Okay. Now notice this one, they didn't give me no fractions. So that means that number 15, they're probably going to give us a fraction, okay? So we're going to do the same thing for the functions. Find the domain or determine the domain of the sum, difference, or product. All right, y'all, so let me see what these functions are. F of x equals 1 over x minus 5. G of x equals 7x to the cube. All right, y'all, so let's start with our sum. That's going to be f plus g of x. That's going to equal my f plus my g. So, y'all, that's 1 over x minus 5. And then g was a 7x to the third. So the domain will start out with that, x such that. All right, y'all, any guesses on this domain? Actually, would this one be all real numbers? No, good job. You cannot include a 5 because y'all right here, if this x was a 5, 5 minus 5 would make that 0, which makes it undefined. So good job. So our domain will be x such that x is a real number. and x cannot equal a positive 5. Now remember, if you had to, you could set the bottom equal to 0 on that one. You can set x minus 5 equal to 0, solve that by adding 5, and you get x equals 5. So since that 5 puts in that and makes that a 0, we're excluding it. So y'all, let's do the difference. That's going to be f minus g of x. That's going to equal your f minus your g. So 1 over x minus 5 minus what? A 7x to the third. And y'all, of course, this is going to be exactly the same, right? You put a 5 into that, that makes that undefined. And you cannot subtract anything from undefined. So since it's got the only fraction, we're going to exclude that 5 again. So x such that x is a real number and x cannot equal a positive 5. All right, then you had the product. F times g of x will equal your f times your g. So y'all 1 over x minus 5. G was a 7x to the third. But once again, you got the same fraction sitting here. And that x still cannot equal 5. So x such that x is a real number. And x cannot equal a positive 5. So once again, the sum, difference, and product had the same domains on those, okay? So really, if you can find the domain of one of them three, it's going to be the same, okay? All righty, y'all. So 16 is the last one in section 2.4. So they just want to know for the functions, determine the domain of f divided by g. Now they're giving me f of x equals 9x minus 4. G of x equals 4x minus 20. All right, y'all. So f divided by g of x. So let's put the f on top. 9x minus 4. That's divided by the g. 4x minus 20. So here's my question. Are y'all excluding any numbers from that domain? Hold on, y'all are saying no. Hold on. Y'all are not excluding any numbers from this domain? But y'all, that's a fraction sitting there. Oh, And I do have a variable down there, so there is one number that this x cannot equal. Hey, so what number can that x not equal? All right, so since I have a fraction, if nothing else, I'm going to take that bottom, 4x minus 20, and we'll set it equal to 0. So let's see. To solve this, I'm going to add 20. So I get 4x. Those cancel. That's going to equal 20. And then I'm going to divide both sides by 4. So all that cancels, giving me a 1x. 20 divided by 4 is 5. So it looks like we're kicking a 5 out of this domain because 4 times 5 is 20. And 20 minus 20 gives me a 0. So your domain will be x such that x is a real number and x cannot equal a positive 5. Okay, y'all. So on the division, you're definitely going to kick out something on that one, okay? All righty, y'all. So that gets you through 2.4. So what we're going to look at next, there's about 5 support problems for 2.4 that I wanted to go over with you um, to get y'all ready for that, okay? And this is just more help for what you got to do today. So for the 2.4 support, the first one says simplify. They're giving me 7d minus 2 minus parentheses 4 minus 5d. So y'all, this one was to get y'all used to these subtractions of these parentheses. Remember, to drop these parentheses, I'm going to distribute that negative. Okay? So I get a 7d minus 2. Negative times a positive will make that a negative 4. Negative times a negative will make that a positive 5d. So, can you go further? And if you can go further, what would you get? So I'm just checking y'all on how y'all add these like terms together, okay? So let me see. What did y'all get? 12d, because 7 and 5, that's going to give you 12d. And then negative 2 and negative 4, y'all getting a negative 6. Perfect. So 12d minus 6. Good job, y'all. All right, number 2 says multiply. So they got a negative 2 times 6a plus 5b. So here you go. Y'all multiply this through. What is negative 2 times 6a? So negative 12a, good job. All right, what's that negative 2 times 5b? That's what, a negative 10b. Now, these are not like terms, so we cannot go any further. All right, let's see what y'all do here. We're going to multiply this next one. 7c cubed times 2c. So y'all, first you want to multiply the numbers. 7 times 2 would give us what, 14? But what would y'all get when you multiplied this c cubed times a c? So you would treat this c like it has a 1 there, and you get c to the 4th. Good job. Okay? So remember, the numbers multiply, the variables, although you're multiplying them, you're adding exponents. All right, 4 was just getting you ready for what we did today. W minus G times W minus G. Just getting you ready for your foiling, like some of these I did. Remember when I did the G times G earlier? So just getting you ready for that. So y'all, here we go. W times W is a W squared. W times a negative G is a negative GW. So I'm just going to put my variables in alphabetical order. Now, negative G times W is a negative GW. So when you're multiplying the same things times each other, like this W minus G times a W minus G, these middle terms always match, okay? Now what we got here? A negative G times a negative G is a positive G squared. Okay, so remember, all these variables have ones by them. Okay, so now you're going to add the variables in the middle. So bring down your W squared, negative 1GW, and a negative 1GW give you a negative 2GW. And y'all, at the end is a positive G squared. Now, MATLAB will take this GW, or you could do WG here. It don't matter. It'll take it either way. I'm just more used to putting my stuff in alphabetical order, but either way, y'all. Okay? All right, y'all. Support has one more. It has the x cubed plus 8 times the x cubed plus 8. So what do y'all get when y'all multiply this? X cubed times x cubed. So give me the exponent. That'll be an x to the what? All right, x to the 6. Good job, because 3 plus 3 gave me 6. All right, y'all, watch this. X cubed times 8 is an 8x cubed. All right, then you do that. 8 times x cubed is an 8x cubed. All right, then finally I got what, an 8 times 8, which is 64. All right, so for me, my only like terms is in the middle. So I'll bring down my x6. Now, what messes people up the most on this is when they add these like terms, they change this. Somehow they add the x's. But remember, you cannot change the variables when you're adding. You can change the numbers. 8 and 8 give you 16. But x cubes plus x cubes is still x cubes, okay? And then at the end, bring down your 64. Just remember, the only time you can change the exponents is when you multiplied. When you're adding, they gotta stay the same on those exponents, okay? All right, y'all, questions on that? So this support was just to get you ready for 2.4, where you had to do all that multiplying and adding and subtracting and all that fun stuff, okay? So y'all, questions on anything we've done today? Hey, I'm just looking on here real quick. Amani, yeah, after this class, it usually takes me about 30 minutes to get it uploaded into YouTube. But as soon as I get it uploaded there, I will be sending it out for you, okay? All right, did y'all have any issues on homework yesterday? All right, y'all, so what I'm going to do, I will let y'all go, and I'm going to pull up the screen back for me. If y'all got any issues in the next hour, you can get online, and I will see if I got anything to help y'all with, okay? So I will reload this page back up, the Zoom meeting, in case y'all got any issues, okay? All right, y'all. So I will let y'all go, and I will bring it back up for anyone that needs me in the next hour. Y'all have a good day, and I will see y'all tomorrow morning at